This short video will show you how to work some of the problems that you're going to see in the Chapter 14 My Stat Lab homework. I've picked a couple problems from the textbook, but these are similar to ones that you'll see in your assignment in My Stat Lab. So the first problem I picked here is from Chapter 14 again, and it's problem number 7, and they're talking about toasters. And the manufacturer ships the toasters in cartons of 20. So that's going to be our N. In each carton they estimate a 5% chance that one of the toasters will need to be sent back for minor repairs. So there's my probability of success, 0.05. What is the probability that in a carton there will be exactly 3 toasters that need repair? Okay, the easiest way to do this problem is to go into StatCrunch and go to Stat and Calculators, and we're going to use the Binomial calculator. And so we know that there are, what did we say in the box? There were cartons of 20. So we have 20 in a box, and we said the success probability was 0.05, and we wanted to know the probability that there are exactly 3 toasters. So I'm going to put 3 in here, I'm going to put in equal, and then compute. And there's my probability. So the probability of exactly 3, and you're going to be asked to round to 4 decimals, so it's 0.0596. So the probability here, probability that x equals 3 equals 0.0596. Probability, make sure we captured that correctly, 0596, yeah. Okay, so that's how you use the binomial calculator in StatCrunch. Now let's go to another problem where we've got the density probability density all worked out here, and we want to know the actually the expectation, or the mean, and the standard deviation. Now this can be done quite easily in StatCrunch by entering in those probabilities, x and the probabilities. So let me show you how you would do that. You're going to put this into one column, and you're going to put the probabilities into the next column. So let's go back to StatCrunch, and we'll just start with a worksheet here, and I'm actually going to label this as x, and then this is going to be the probability of x that was given to me in the problem. So in this problem they told me that the probability of no red lights on the way home was 0.05, and then for 1 red light they told me the probability was 0.25, and for, oops, go down 1, for 2 red lights the probability was 0.35. For 3, the probability was 0.15, 0.15, and for 4, the probability was 0.15, and for 5 red lights, the probability is 0.05. And remember, these should add up to 1, right? So what do we have? 30, 65, 80, it adds up to 1. Okay, so now all you have to do here is go up here to Stat, Calculator, and we do this as a custom. And we tell it where the values are, the x values, and where the probabilities are, and then just hit compute. And so it's going to give me the mean. Okay, so the question asked me what was the mean number of traffic lights you'd expect to hit each day. So for A, the expected value of x equals, what did we get? 2.25. And then the second one was the standard deviation. And again, my little custom calculator will do that for me. And my standard deviation was 1.26 if I round. I'm not sure what my stat lab will ask you for in terms of rounding. So there's an easy way to do those calculations without having to do it by hand in your calculator. Okay, and then I have another problem, and again you have one like this in your My Stat Lab homework. You play 2 games against the same opponent. The probability that you win the first game is 0.4. If you win the first game, the probability you also win the second is 0.2. If you lose the first game, the probability you will win the second is 0.3. So the first question is, are the games independent? Explain. Well, notice that the probability of winning is not staying the same. The probability that you win the first game is 0.4. If you win the first game, actually the probability of winning the second game goes down. So the 2 games are not independent. Now what's the probability that we get a loss and a loss? Okay, so remember there's 4 outcomes here total. What can we have? Let's just type in the outcomes in our sample space. We could have a win and a win and a loss, whoops, a loss and a win, and then, sorry about that, loss and a loss. So there's 4 outcomes we can have. So let's do a loss and a loss. So if the probability you win the first game is 0.4, then the probability to lose the first game must be 0.6. Now, it says if you lose the first game, the probability you'll win the second game is 0.3. So if you lose the first game, the probability you'll lose the second must be 0.7. And we just multiply these together because these are already, this is a conditional probability. This is the probability of losing the second game given you lost the first game. So there's the probability of 2 losses. So I went ahead and I added that here into my little table. Now what's the probability of a win followed by a win? Okay, the probability that you win the first game is 0.4. All right, and then it says if you win the first game, the probability you win the second game is 0.2. So 0.4 times 0.2, 0.08. So there's about an 8% chance that I win both games. So how do I figure out the probability of winning exactly one game? That would be these middle 2 outcomes. I could multiply probabilities, but I can just use my complement rule. Notice this adds up to 0.5. So this must be 0.5. And again, in StatCrunch, I can just go and get my go ahead and put my numbers in here. What do I have? 0, 1, 2, so I don't need these here. I can get rid of these other columns, and I'm just going to go ahead and put the x's and the probability of x back in just like we did before. So probability of no games here, this is 0.42, and this one was 0.5, and this one was 0.08, and then I'm going to go ahead and erase these because I don't need these anymore. I only have 2 outcomes, and then again go into Stat, Calculator, Custom, tell it where the x's are, tell it where the probability of those are, and compute. And so it'll go ahead and compute the mean for me, 0.66, so I expect to win about 0.66 games, and my standard deviation is 0.62. So that should help you in terms of how to use those little density tools to work out the problems in Chapter 14.